Picture this. You're in a dark security operations center. Dashboards are glowing, logs are streaming by the millions, and neural networks are visualizing threats in real time. It sounds awesome, right? Well, welcome to today's Explainer. We're diving into a critical, frankly terrifying vulnerability that's quietly creeping into enterprise environments. We're talking about AI hallucinations. And no, not the funny ones where a chatbot gives you a bizarre recipe. We're getting into how these hallucinations can silently corrupt your enterprise cybersecurity data lakes.
So think about this. What happens when the AI protecting your enterprise starts believing information that literally never existed? Imagine millions of security events dumping into your data lake every single day. You've got endpoint telemetry, cloud activity, firewall logs, the whole shebang. Now imagine your AI system chewing on all that data. It spots a threat, creates an incident, and even recommends an automated response. Sounds super efficient. But there's a massive problem. The threat? It's not real. The AI completely hallucinated it. And when that fabricated threat slips into your data lake, well, it's no longer just a wrong answer. It actually becomes bad security data that can trigger some seriously disastrous operational actions.
Okay, so here's our architectural roadmap for this explainer. First, we'll look at the AI security problem. Second, inside the data pipeline. Third, proving hypotheses. Fourth, guardrails and quarantines. And finally, we will wrap up with the golden rule.
Number 1, the AI security problem. Let's dive right in.
To really get this, we need to look at what an AI hallucination actually looks like in practice. On one hand, you have real, authoritative telemetry. Think of a log clearly showing an authentication coming from Hyderabad, India. Perfectly normal. But then, on the other hand, the AI completely fabricates a story. It suddenly claims the user authenticated from Russia at 3:42 a.m. Now, it sounds highly plausible, but it's pure fiction. If we aren't careful here, this ghost story just blends right in and becomes trusted security telemetry. And frankly, it's a bit terrifying how convincingly an AI can just invent an international cyber attack out of absolutely thin air.
Number 2, inside the data pipeline. Let's look under the hood.
So in a standard AI data pipeline, you basically have 4 steps: collection, normalization, AI analysis, and detection. Now, the biggest architectural mistake an organization can make happens right between steps 3 and 4. This is the absolute critical vulnerability. Just imagine your AI enriches a firewall log, gets it wrong, and generates a malicious IP address that doesn't actually exist. Then that false value is written right back into the authoritative record. Boom! Instant data contamination. By doing that, we're literally allowing AI-generated information to sneak into the exact same trusted data path as our true authoritative telemetry.
The absolutely crucial point here is establishing a strict, non-negotiable architectural boundary. You must never, ever treat AI output as raw telemetry. Your data has to be categorized into 2 completely distinct layers. Layer 1, that's your authoritative security data, the absolute ground truth, your firewall logs, your authentication events. Layer 2 is your AI-derived intelligence. This is where your risk scores and hypotheses live. Now, Layer 2 is absolutely allowed to interpret Layer 1. That's its job, but it should never, under any circumstances, silently rewrite it. Because if we failed to separate those layers, we end up triggering a really dangerous AI feedback loop. Just picture this. The AI hallucinates a threat classification, and that bad data gets shoved into your data lake without any labels warning us what it is. Later on, future AI analysis retrieves that exact same fabricated data and treats its own previous wild guess as hard evidence. The AI is essentially eating its own hallucinations. It creates this catastrophic loop of blind trust that absolutely destroys your data integrity.
Number 3, proving AI hypotheses.
Okay, so how do we fix this? Well, instead of allowing an AI model to just blindly shout, "Hey, this user is compromised," we force it to build a case. Kind of like a detective. If the AI's hypothesis is an account compromise, it must provide concrete evidence. It needs to point to things like a successful authentication from an unusual geography, a new device registration, maybe an MFA configuration change, or a privileged role being activated. You see, the AI isn't simply generating a lazy conclusion anymore. It is actively constructing an evidence-backed hypothesis using multiple independent signals. The architectural rule here is crystal clear. No evidence means no high-confidence conclusion. Period. Now, to actually get that evidence, we typically use retrieval augmented generation, or RAG. RAG is great. It allows the system to pull actual enterprise records, like real sign-in logs or endpoint alerts, right before generating an answer, which really grounds its logic. But, and here is the catch you absolutely must remember, RAG does not automatically eliminate hallucinations entirely. It just doesn't. Even with RAG in place, the retrieved data still has to be rigorously validated.
You might see a confidence score of 0.87 or 87%. You look at an AI output with a high score like that and think, awesome, it's definitely correct. Well, let me warn you right now, an AI can be extremely confident and still be completely, unequivocally wrong. It's crazy, but true. You can never confuse model confidence with actual truth. Modern enterprise security architectures have to combine model confidence, evidence quality, and source reliability. You can't just rely on the model's confidence score alone.
Number 4. Guardrails and quarantines. Let's talk defense.
To really protect the data lake, every single security record has to be able to answer exactly where it came from. We do this by enforcing a really strict data provenance schema. Basically, we explicitly tag records with a source type of AI-derived. We list the specific model ID, we stamp it with a timestamp, and most importantly, we require evidence references. By validating this exact schema the moment it's ingested, we make sure AI-derived data is never indistinguishable from our raw telemetry. If an AI tries to sneak in a free-form conclusion without this strict structure, the pipeline just rejects it entirely. No way.
But we actually take this a step further by building physical architectural checkpoints. Welcome to the AI quarantine zone. In this step, any AI-generated security intelligence is treated as completely untrusted input. It just sits there, totally isolated in this quarantine environment until it passes thorough evidence validation. It's only after that evidence is fully verified by independent, authoritative sources that it's allowed to move to step 4 and actually become validated intelligence.
Now, it's not just the AI's output we have to worry about. It's actually the input, too. Security logs must be treated as untrusted content to prevent prompt injection. Think about it. Security data, like malicious emails or weird web requests, often contains text controlled by an attacker. If an AI system processes that content without proper isolation, the attacker could be attempting an indirect prompt injection, basically trying to trick and manipulate your model. That is exactly why your security data and your AI system instructions must remain strictly separated. The AI has to understand that the data is evidence to be analyzed, not instructions to be followed.
Number 5. The golden rule. Let's bring it all together.
So if there is one crucial point, one absolute core axiom you take away from this entire explainer, it has to be this. AI should interpret security evidence, not become the evidence. Your firewall logs, your identity logs, your endpoint telemetry, that is your evidence. An AI-generated explanation is simply an interpretation of that evidence. Those two things must never, ever be treated as identical. In the world of cybersecurity, the quality of your decisions can never exceed the quality of the raw evidence behind them.
Look, AI is incredibly powerful. It can investigate alerts and summarize complex incidents way faster than any human ever could. But the more authority we give it, the more absolutely vital data integrity becomes. A hallucination in a customer service chatbot, that's just annoying. A hallucination inside an enterprise security data pipeline, that is a massive operational risk. We aren't trying to eliminate AI, but we absolutely must architect around its limitations. So I'm going to leave you with this chilling, provocative question to think about. Would you trust an AI system to automatically isolate a production server based only on its own threat analysis? Thank you for exploring this with me today. Keep building those guardrails.